My dear students, welcome back to our channel. Students, in this video I am explaining JNTU Hyderabad MBA first semester. Subject Research Methodology and Statistical Analysis. Important short and long questions and answers. Let's start quick revision. Next fourth unit. Fourth unit. First important short question is: what is ANOVA? ANOVA, analysis of variance, is a statistical method used to compare the means of three or more groups to see if they are significantly different from each other. Example: a teacher wants to know if students' test scores differ based on the type of study method, self-study, group study, tutoring. ANOVA helps compare the average scores of each group. Conclusion: ANOVA helps determine if the differences in group means are due to a real effect or if they occurred by chance. If the p-value is low, we conclude there are significant differences. Next important short question is: why do we do discriminant analysis? Discriminant analysis is used to classify data into different groups or categories based on certain features. It helps to predict which group a new observation belongs to based on the values of input variables. Example: in a bank, discriminant analysis can be used to classify loan applicants as either high risk or low risk based on factors like income, credit score, and loan amount. Conclusion: discriminant analysis helps us make decisions and predictions about which category an observation belongs to based on its characteristics. First important long question is: one-way and two-way ANOVA, with and without interaction. One-way and two-way ANOVA, with and without interaction. One-way ANOVA. Purpose: it compares the means of three or more groups to see if they are different from each other. Example: a teacher wants to know if students' test scores differ based on the type of study method used. The methods are Group 1, self-study; Group 2, study with a tutor; and Group 3, group study. One-way ANOVA can help determine if the mean test scores differ among these groups. Without interaction, there's no interaction between other factors. We are only looking at one factor. Example: study method. Two-way ANOVA. Purpose: it compares the means of two factors, each with two or more levels, to see if there is an effect of each factor and if they interact. Example: a company wants to study the effect of two factors: work environment, office versus home, and work hours, part-time versus full-time, on employee productivity. Two-way ANOVA will determine if 1. There's an effect of work environment on productivity. 2. There's an effect of work hours on productivity. 3. There's an interaction between work environment and work hours. Example: maybe productivity in the office is better for full-time employees than part-time. With interaction, this shows if the effects of one factor depend on the other. For example, if part-time workers do better at home but full-time workers do better in the office, that's an interaction. Without interaction, this means the two factors' effects are independent. It assumes the effect of one factor doesn't change depending on the other. Conclusion: one-way ANOVA compares multiple groups for one factor. Two-way ANOVA compares multiple groups for two factors and can check for interaction. With interaction shows how factors influence each other. Without interaction assumes factors influence outcomes independently. Next important long question is: Chi-square test for independence of attributes. The chi-square test for independence is used to determine if two categorical variables are independent or related. It tests if there is a significant association between the two variables. How it works? The test compares the observed frequencies, what you actually seeing, the data with the expected frequencies, what you would expect if there were no association. If the observed frequencies are significantly different from the expected frequencies, the variables are considered related. If they are not different, the variables are independent. Example. Imagine a survey that asks people if they prefer coffee or tea and whether they are a morning person or night person. The two variables here are drink preference, coffee or tea, and time of day preference, morning or night. We want to see if drink preference is related to whether someone is a morning person or a night person. Here's a simplified table of the survey results. Morning person, night person total. Steps. 1. Calculate the expected frequencies. For example, the expected frequency for coffee and morning person is calculated as expected is equal to row total times column total grand total is equal to 50 times 40, 100 is equal to 20. 2. Compare the observed and expected frequencies. If the differences are large, we might conclude there is a relationship between drink preference and time of day preference. 3. Perform the chi-square calculation. The formula for chi-square is where O is the observed frequency and E is the expected frequency. 4. Check the p-value. If the p-value is smaller than a certain threshold, usually 0.05, it suggests that there is a significant relationship between the variables. Conclusion. The chi-square test for independence helps us determine if two categorical variables are related or independent. In the example, if the p-value is small, we would conclude that drink preference is related to being a morning or night person. If the p-value is large, it means they are independent and the time of day does not affect drink preference. Next important long question is Carl Pearson's coefficient of correlation. Carl Pearson's coefficient of correlation, R. Carl Pearson's coefficient of correlation is a statistical measure used to determine the strength and direction of the relationship between two variables. It gives us an idea of how closely two variables are related to each other. Formula. The formula for Pearson's correlation coefficient is where n is the number of data points. X and y are the variables. xy is the product of the corresponding values of x and y. Interpretation of R. R is equal to +1, perfect positive correlation. As one variable increases, the other increases. R is equal to -1, perfect negative correlation. As one variable increases, the other decreases. R is equal to 0, no correlation, no relationship between the variables. 0 R1, positive correlation, both variables increase together but not perfectly. 1 R0, negative correlation, one variable increases while the other decreases but not perfectly. Example. Let's say we have data on the number of hours studied, kiss smiley and test scores, y, for 5 students. In this case, as the number of hours studied increases, the test score also increases. We can calculate the Pearson correlation coefficient, R, to measure the strength of this relationship. Conclusion. Pearson's correlation coefficient helps us understand how two variables are related. If the value of R is close to +1 or -1, there is a strong relationship between the variables. If R is close to 0, it indicates no significant relationship. Next important long question is Spearman's rank correlation. Spearman's rank correlation. Spearman's rank correlation is a statistical method used to measure the strength and direction of the relationship between two variables based on their ranks rather than their actual values. It is especially useful when the data is not normally distributed or when the relationship between the variables is not linear. Formula. The Spearman's rank correlation coefficient, denoted as ρ, is calculated using the following formula, where D is the difference between the ranks of each pair of values. N is the number of data points. Steps to calculate. 1. Rank the data. Assign ranks to each value in both variables. 2. Calculate the differences, D, for each pair. Subtract the rank of one variable from the rank of the other. 3. Square the differences. Find D superscript 2 for each pair. 4. Apply the formula. Sum the squared differences, then apply the Spearman's rank formula. Interpretation of ρ. ρ is equal to +1, perfect positive rank correlation. Both variables increase together. Ρ is equal to -1, perfect negative rank correlation. As one variable increases, the other decreases. Ρ is equal to 0, no rank correlation, no relationship between the variables. 0 ρ 1, positive rank correlation. 1 ρ 0, negative rank correlation. Example. Let's say we have data on the number of hours studied, kiss smiley, and the test scores. Y, for 5 students. Step 1. Rank the data, lowest to highest for both X and Y. Ranks for X 1, 2, 3, 4, 5. Ranks for Y 1, 2, 3, 4, 5. Step 2. The differences, D, between ranks are all 0, so ρ is equal to 1, perfect positive rank correlation. Conclusion. Spearman's rank correlation measures the strength and direction of the relationship based on the ranks. It's helpful for nonlinear relationships or when data is not normally distributed. If ρ is close to +1, the variables have a strong positive relationship. If close to -1, they have a strong negative relationship. Next important long question is linear and multiple regression analysis. Linear and multiple regression analysis. Regression analysis helps us understand the relationship between a dependent variable, the one we are trying to predict, and one or more independent variables, the predictors. It is used to model and analyze these relationships. 1. Linear regression. Purpose. Linear regression is used when we have one independent variable and we want to predict the dependent variable based on a straight line relationship. Equation. The general form of the linear regression equation is y is equal to a plus bx, where y is the dependent variable, x is the independent variable, a is the y-intercept, b is the slope, the change in y for a one-unit change in x. Example, suppose we want to predict a person's weight, y, based on their height, x. We can collect data for height and weight and use linear regression to find the line that best fits the data, allowing us to predict weight from height. Interpretation: if the slope, b, is positive, it means as height increases, weight increases. 2. Multiple regression. Purpose: multiple regression is used when there are two or more independent variables. It helps predict the dependent variable based on the relationship with all the predictors. Equation: the general form of the multiple regression equation is where y is the dependent variable, x_1, x_2, x_n are the independent variables. b_1, b_2, b_n are the coefficients, the impact of each independent variable. Example: suppose we want to predict a person's income, y, based on their education level, x, and years of experience, x. Multiple regression will help us understand how both education and experience together affect income. Interpretation: in multiple regression, each coefficient, b, shows how much the dependent variable changes with a one-unit change in the corresponding independent variable, holding other variables constant. Conclusion: linear regression is used when we have one predictor to predict the dependent variable. Multiple regression is used when we have more than one predictor. Both techniques help model relationships and make predictions, with multiple regression offering more flexibility when dealing with several influencing factors. Next, fifth unit. Fifth unit. First important short question is time series analysis. Time series analysis is a method used to analyze data that is collected over time to identify trends, patterns, and forecast future values. Example: a company tracks its sales every month. Time series analysis helps identify patterns such as seasonal peaks in sales during holidays, and it can be used to predict future sales. Conclusion: time series analysis is useful for understanding past behaviors, identifying trends, and making predictions about future events based on historical data. It is commonly used in areas like finance, economics, and sales forecasting. Next important short question is index numbers. Index numbers are statistical measures used to compare the relative changes in variables over time, between locations, or across different items. Example: the Consumer Price Index, CPI, is an index number that tracks changes in the average price level of goods and services over time. If the CPI increases, it indicates that prices have gone up. Conclusion: index numbers simplify comparisons by converting data into a standard format, making it easier to understand trends, inflation, or changes in economic variables over time or across regions. Next important long question is types of index numbers. Types of index numbers. Index numbers are statistical tools used to measure changes in variables like prices, quantities, or economic indicators over time. There are several types of index numbers, and they are used in different situations. The most common types are 1. Price index numbers. These measure the changes in the price level of a specific group of goods or services over time. They help track inflation or deflation in an economy. Example: the Consumer Price Index, CPI, measures the change in prices of goods and services like food, clothing, and housing that a typical consumer purchases over time. If the CPI increases, it indicates inflation. Prices are rising. 2. Quantity index numbers. These measure changes in the quantity or volume of goods or services produced or consumed over time. They help in understanding changes in production or consumption patterns. Example, a company tracks the number of units of a product sold each year. If sales increase over time, a quantity index helps measure the percentage change in sales. 3. Value index numbers. These measure changes in the value, price times quantity, of goods or services over time. They are useful for understanding overall market or economic trends. Example, a value index can be used to track the overall value of agricultural products in a country. If both prices and production increase, the value index would show a rise in total value. 4. Wholesale Price Index, WPI. This measures the changes in the wholesale prices of goods in the market. It is often used to assess inflation at the wholesale level. Example, the WPI can track the price changes of raw materials or products before they reach the retail market. If the WPI increases, it indicates that the prices of goods at the wholesale level are rising. 5. Consumer Price Index, CPI. This measures the average change over time in the prices paid by urban consumers for a market basket of goods and services. Example, if the CPI rises by 3%, it means that, on average, consumers are paying 3% more for the same goods and services compared to the previous year. Conclusion. Index numbers are important tools for comparing changes in prices, quantities, or values over time. Different types of index numbers, like price, quantity, and value indices, are used for specific purposes, such as tracking inflation, production, or economic performance. They provide valuable insights into economic trends and help in decision-making. Next important long question is, what is the concept and importance of research report writing? Briefly, explain the importance of tables and charts in it. Concept and importance of research report writing. Research report writing is the process of presenting the findings of a research study in a structured format. It includes the introduction, methods, results, discussion, and conclusions of the research. The main goal is to communicate research results clearly and logically so others can understand, evaluate, and possibly replicate the study. Importance of research report writing. Clear communication. Research report writing helps researchers present their findings in a structured and understandable way. Documentation of results. It ensures that the research methods and results are documented for future reference and validation. Contribution to knowledge. It allows researchers to share their findings with the scientific community, contributing to the body of knowledge. Professionalism. Well-written reports demonstrate the researchers' professionalism and the credibility of the study. Importance of tables and charts in research reports. Tables and charts play a crucial role in presenting data clearly and effectively. They help summarize complex information and make it easier for readers to interpret the results. 1. Clarity and simplicity. Tables and charts simplify data by breaking it into digestible pieces. For example, a table may show survey results for different groups, making it easier to compare values at a glance. 2. Visual representation. Charts like bar graphs, pie charts, or line graphs Provide a visual representation of data, highlighting trends, patterns, or comparisons. For example, a line graph showing sales growth over time makes it easier to see fluctuations compared to just reading numbers. 3. Enhancing interpretation. Well-designed tables and charts help the reader quickly identify key trends, relationships, and comparisons. For instance, a bar chart showing the growth of different departments within a company over several years makes it easier to see which department is performing the best. Example, a research report on student performance might include a table showing test scores and a bar chart showing the performance of students from different schools. This makes it easier to compare and understand the results. Conclusion: research report writing is vital for effectively communicating research findings, while tables and charts make complex data more accessible, clear, and easier to understand. Next important long question is report preparation and presentation. Report preparation and presentation. Report preparation is the process of organizing and compiling information, analysis, and findings into a clear and structured document. It is a key skill in both academic and professional settings, as it helps communicate ideas, research, or results in a formal way. Steps in report preparation. 1. Understanding the purpose. Know why you are writing the report. Is it to inform, analyze, or persuade? For example, a report for a business might aim to analyze market trends, while a research report might present findings of a study. 2. Research and data collection. Gather relevant information. This could include reading documents, conducting interviews, or gathering statistical data. For example, if preparing a report on employee satisfaction, data from surveys and interviews would be gathered. 3. Organizing the content. Arrange the information logically. Common sections in a report include introduction, background, and objectives. Methodology, how data was collected. Findings, results, what the research or analysis found. Conclusion, summarizing the results. Recommendations, if applicable, suggestions based on findings. 4. Writing the draft. Begin writing the report in clear, concise language. Avoid jargon and ensure each section is easy to follow. A report might include text, tables, charts, or graphs to support findings. 5. Revising and editing. Review the report for clarity, accuracy, and flow. Check for grammatical errors and ensure the content aligns with the purpose of the report. 6. Finalization. After revisions, prepare the final version of the report for submission or presentation. Report presentation. Presentation refers to how the report is shared with an audience, often through slides or a speech. The goal is to communicate the report's key findings in a clear, engaging way. Visuals. Use visuals such as charts, graphs, and images to support key points and make the information more digestible. Clarity. Focus on presenting the most important information. Avoid overwhelming the audience with details. Practice. Rehearse your presentation to ensure smooth delivery. Example. For a business report on sales growth, the report might include data on monthly sales figures, a bar chart showing growth trends, and a conclusion offering recommendations for improving sales. Conclusion. Effective report preparation involves collecting and organizing information, writing clearly, and structuring the content. Presentation involves sharing the findings in a visually engaging and concise way. Both skills are essential for successful communication in professional and academic contexts. Next important long question is, what is the basic structure of a report? Explain it in detail. Basic structure of a report. The basic structure of a report consists of several sections that help organize the information in a clear, logical manner. Each section serves a specific purpose, making it easier for readers to understand the purpose, methods, findings, and conclusions of the report. 1. Title page. The title page includes the report's title, the author's name, the date, and any other relevant information, example, the name of the organization or course. Example. Title, Annual Sales Report for 2024. Author, John Doe. Date, 15th March 2025. 2. Table of Contents. This section lists the main sections of the report with page numbers, helping readers navigate the document quickly. 3. Introduction. The introduction provides background information and states the purpose of the report. It sets the context and outlines the objectives. Example. The report might explain that the purpose is to analyze sales growth and identify trends for better business decisions. 4. Methodology. This section explains how the research or analysis was conducted. It describes the methods used to collect data, such as surveys, interviews, or data analysis. Techniques. Example. In this report, sales data was gathered from the company's records over the past 12 months and analyzed using statistical tools. 5. Findings or results. This section presents the data, observations, or results obtained from the research or analysis. It includes facts, figures, and any patterns identified. Example. Sales increased by 10% in the last quarter compared to the previous year, with the highest growth observed in the northern region. 6. Discussion. In this section, the findings are interpreted and analyzed. It connects the results with the objectives, explaining the significance of the findings. Example. One possible reason for the increase in sales could be the successful marketing campaign launched in the northern region. 7. Conclusion. The conclusion summarizes the key points of the report and restates its main findings or results. It may also suggest recommendations based on the findings. Example. Based on the analysis, it is recommended that the marketing strategy used in the northern region be expanded to other areas. 8. Recommendations, optional. This section suggests actions or solutions based on the report's findings. Example. To sustain the growth, it is recommended to increase product availability in high-demand regions. 9. References. This section lists any sources, research papers, articles, or websites used to gather information for the report. 10. Appendices, optional. Any additional material, such as raw data, detailed charts, or extended analysis, is placed in the appendices. Conclusion. The structure of a report is designed to provide clear and organized information. Each section has a specific role, from introducing the topic to summarizing the findings and offering recommendations. This organization ensures the report is easy to follow and understand. Next important long question is types of research reports. Types of research reports. Research reports come in different forms depending on the purpose, audience, and type of research. The main types of research reports include descriptive reports, analytical reports, empirical reports, and theoretical reports. Each type serves a unique purpose and is used in various contexts. 1. Descriptive research reports. Descriptive reports are used to describe the characteristics of a subject or a phenomenon. They summarize data without interpreting or analyzing it deeply. Example, a report that describes the demographics of a group of people, such as age, gender, education level, and occupation, without analyzing why these characteristics exist. 2. Analytical research reports. Analytical reports involve examining and analyzing data to draw conclusions. They not only describe facts but also interpret and analyze them to identify patterns, relationships, or problems. Example, a market analysis report that not only describes current sales figures but also analyzes trends to understand the reasons behind sales increases or decreases. 3. Empirical research reports. Empirical reports are based on research that involves collecting original data through observation, experiments, or surveys. These reports are commonly used in scientific research, where findings are based on direct evidence. Example, a scientific research paper that reports the results of a clinical trial for a new drug, including experimental design, data collection, and analysis. 4. Theoretical research reports. Theoretical reports focus on exploring theories or concepts rather than collecting original data. They analyze existing knowledge, theories, or ideas to propose new frameworks or interpretations. Example, a report discussing the application of psychological theories to understand human behavior in specific environments. 5. Technical research reports. These reports provide in-depth details about specific technological processes, systems, or developments. They are often used in engineering, IT, or scientific fields. Example, a technical report on the design and functioning of a new computer software or machine. 6. Proposal reports. A proposal report presents a plan or idea, often with the purpose of seeking approval or funding. It includes the problem, objectives, proposed solution, and expected outcomes. Example, a research proposal submitted to a funding agency outlining the goals, methods, and expected results of a scientific study. Conclusion. Different types of research reports serve various purposes, from simply describing data to analyzing findings, conducting experiments, exploring theories, or proposing solutions. Each type is important for its specific use, and understanding the appropriate report type helps in effectively communicating research results.